Hello everyone, my name is Muhammad Waqas. I am a graduate student at Memorial University of Newfoundland, Canada. I am doing my Masters in Electrical Engineering. It's a research-based program and I am working under supervision of Dr. Mohsen Jamil. This video is being recorded as a part of a semester project for a course named as Power System Protection, and the course code for this course is ENGI-9862. And the title of the project on which I have done design and simulation in MATLAB is Design of Undervoltage and Overvoltage Protection Scheme for Radial Power System. So I will start this presentation with a brief introduction of actually what power system protection is. A power system protection deals with the protection of electrical power systems from the faults through disconnection of faulted parts from the rest of electrical networks. Now, the faults or problems in power system may occur due to various reasons. Some of them are listed below, which are short circuits, abnormal conditions such as a sudden rise in load or sudden decrease in load, or equipment failure such as on the generation side. So the main aim to develop this project or to design this project is to develop a protection scheme against both undervoltage and overvoltage scenarios, ensuring the safety of radial power system and the safety of sensitive and expensive load side equipment commonly found in industries and households. The main objective is to prevent potential damage that may occur due to instability in AC mains supply, such instabilities can generate losses in electrical circuit, resulting in low power factor and wastage of considerable power. The power quality can be substantially impacted by voltage fluctuations, and there is a chance that the priceless and expensive equipment could be harmed. To address this issue, the project proposes the implementation of a tripping mechanism to safeguard the radial power system and subsequently load at its downstreams. So here we need to define what actually a radial power system and a network power system is. So a radial power system is a configuration where multiple loads are connected to a single power source. So we can say that radial power system is characterized by multiple loads connected to a single power source, and this design is typically seen in industrial complexes or distribution systems with voltages under 100 kilovolt. Or even though the radial power system is a less expensive setup, but this configuration has reliability issues, since if one of the power sources fail, all the users at its downstreams which are linked to it will lose its service and they will be out of power supply. To address this concern, either mainline reclosers or other sectionalizing devices can be used to open and disconnect loads downstream of the switching device during faults on specific line sections. Alright, although radial power systems have this issue that if power source fails, all the load at its downstreams will be out of the power supply, but radial power systems presents a significantly less complicated problems from the standpoint of protection as compared to the network power systems. So as we can see in this diagram, that there is a one power source, and we can assume this is a transmission line including main transformer, and there are various switches which are used to connect various loads to this transmission line. So in case of any fault, if a fault happens in this transmission line and it trips the complete line and the loads at its downstreams, they will all be out of the power supply. For example, in this case, we can assume that if a fault occurs after switch 1, then the load after switch 1 will be out of power and the loads before this switch can get supply. So that's a major issue with this system. Similarly, a network power system is a configuration that incorporates multiple sources and multiple interconnected loops between these sources and the load. So it means that there are multiple sources and multiple loads which are connected parallelly. So in case if one of the source gets deactivated due to any fault, all the loads are not suspended from the power supplies because they are getting power supplies from another source on another route. So the network power systems are mainly used for transmission systems that generally operate at a voltage of 100 to 200 kilovolts and above. Moving next to I have used a terminology named as NERC protection system here. So what is NERC? NERC is North American Electric Liability Corporation, which basically it is a non-profit organization which deals with the reliability of power schemes in the North American region. So according to NERC, the protection system is defined as a combination of protective relays, associated communication systems, which are used for the communication and power system, voltage and current sensing devices, and the control circuitry, which controls the circuit. So in this main project, basically I have used two relays which will detect the undervoltage and overvoltage conditions, and they will trip a control circuitry or a circuit breaker which will disconnect the load from the power supply to prevent them from any damage. So here we need to define what basically a relay is. A relay is an electrical device or equipment which detects abnormal power system conditions and initiates corrective action as quickly as possible. So relays can be found everywhere in the modern world. A relay is commonly used in many applications of our daily life. So relay is basically a device with contacts that either opens and closes a switch as a result of input signal, which could be a voltage signal or a current signal applied to a coil. Relays can be mainly classified into two types, either mechanical relays or the solid relays. The mechanical relays have contacts and they use electromagnetic force to mechanically open and close the contacts to turn on or off signals and or current or voltages. As compared to the mechanical relays, the solid state relays do not have mechanical moving parts that the mechanical relays with contacts do. Instead, they consist of semiconductors and electronic parts such as MOSFETs, IGBTs, and transistors, etc. And on the basis of these semiconductor devices, they receive the signals, either voltage or current signals, and operate, perform various operations in the electric circuit. So here I have used under voltage relay, and for each and every electrical equipment there is some standard use worldwide. So for protection system there is some ANSI coding used, which basically assigns a device number to each type of electrical equipment. So in case of under voltage and over voltage relay, the ANSI code 27 is basically used for under voltage relay. That's why it is called as ANSI 27 protection. Whereas for over voltage relay, ANSI code 59 is used. That's why it is called an ANSI 59 protection. So what is under voltage relay and how it works, and what is ANSI 27 protection? I'll define in this slide. The undervoltage relay basically continuously monitors system voltage and initiates appropriate actions if voltage drops below the acceptable limits. Here I have used a word sag. Sag is basically the duration during which the voltage drops below the threshold value or the reference value. In this waveform, the voltage waveform which is given in the slide, we can see that the green portion is the regular wave and the red portion is basically the voltage sag, where voltage has dropped below the threshold value. So sags occur when the root mean square voltage decreases between 10% and 90% for a duration of a half a cycle to 1 minute. I will further explain what are the type of under voltages on the basis of time duration and on the basis of threshold to limit up to which the voltage drops. We can see that there are basically in ANSI 27 protection, there are two types, ANSI 27.1 or ANSI 27.2. In ANSI 27.1, in case of three-phase voltage, each phase voltage is monitored independently, and the protection scheme is activated when any one of the three monitored voltages reaches the threshold value. For example, if we have three phases, and if any one of the phase drops below the threshold value, the protection mechanism activates and trips the circuit breakers or other control circuitry to disconnect the load from the supply. In case of ANSI 27, all the three voltages are monitored together, and the protection scheme is activated when all three monitored voltages reach the threshold. It means that if any one of the phase drops below the threshold, this protection scheme will not activate, and it will activate only when all the three phases will drop below the threshold value. So in this table we can see that there are different types of undervoltage is given: instantaneous undervoltage, momentary undervoltage, and temporary undervoltage. And these voltages are basically classified on the basis of their duration. So if there is a voltage dip for a duration of 0.5 to 30 cycles and its magnitude is zero point 0.1 to 0.9 per unit, so it means that will be instantaneous undervoltage. While if the duration of the undervoltage dip or sag is 30 cycles to 3 seconds and its magnitude is zero point 0.1 to zero point 0.9 per unit, so that type of undervoltage will be momentary undervoltage. And if the duration of undervoltage is 3 seconds to 1 minute and its magnitude is 0.1 to zero point 0.9 per unit, then that undervoltage is defined as temporary undervoltage. Similar to ANSI 27 undervoltage protection, we have ANSI 59, which is basically overvoltage protection. So overvoltage relay is assigned the ANSI code of 59. Overvoltage relay continuously monitors system voltage and initiates the appropriate action if voltage rises above acceptable limits. Here I have used the term swell as there was a sag in the undervoltage case. So swell terminology is used in case of overvoltage. We can see in the graph given below the voltage waveform, the green portion is the ideal or the regular waveform which is required, while the red waveform is the overvoltage peak to peak, and the swell is the duration for which this voltage exceeds above or rises above the threshold value. So swells are defined as an increase in root mean square voltage to over 110% for a duration of a half cycle to 1 minute. Similar to undervoltage, overvoltages can also be classified into three types, which is given in the next slide. So overvoltage protection also can be classified into either ANSI 59.1 or ANSI 59.2. So in ANSI 59.1, each phase voltage is monitored independently and the protection scheme is activated when any one of the monitored voltages drops or rises above the threshold value. While in case of ANSI 59.2, all the three voltages are monitored together and the protection scheme is activated only when all the three monitored voltages reaches the threshold. Similar to undervoltage, the overvoltage can be classified into either instantaneous, momentary, and temporary overvoltage. The durations for the instantaneous overvoltage is 0.5 to 30 cycles, while the magnitude is 1.1 to 1.8 per unit. While in case of momentary overvoltage, the duration is 30 cycles to 3 seconds and magnitude is 1.1 to 1.4 per unit. In case of temporary overvoltage, the duration is 3 seconds to 1 minute, while magnitude is 1.1 to 1.2 per unit. So in case of overvoltage, the magnitude remains same, only duration of the sag varies. While in case of overvoltage, the duration also varies along with the magnitude. So here is the block diagram of my project which I have designed. Basically there's a AC power source, there's a current and voltage and current measurement. A fault has been introduced in this transmission or distribution line. There's a comparator circuit which is continuously monitoring the line voltage along with the reference voltage. So whenever there is a fault, it compares it. If it's below threshold voltage, it gives signals to the under voltage, and if it's above the threshold voltage, it gives signals to the over voltage relay. So it's basically providing data to the relays which are continuously monitoring the voltages, and on the basis of this difference, the over and under voltage provides a signal to the circuit breaker which trips the circuit and disconnects the load at the downstream of this transmission line to prevent it from any damage. This is the Simulink model which I have built in MATLAB Simulink. We can see that there is a three-phase AC source and there is a voltage measurement block which is monitoring the voltages of three phases, and then there is a scope used in this to check the waveform, and this voltage and current signal is being provided to overvoltage relay block which is named as V59 because 59 is its ANSI device number, and similarly, this signal is provided to 27 under voltage relay whose ANSI device number is 27. On the basis of if the voltage, line voltage, if it's dropped below, under voltage relay activates, and if voltage rises above the threshold value, the over voltage relays operates and it provides signals to this circuit breaker here, and this circuit breakers disconnect the three-phase load at the downstream of this transmission line and disconnects it from disconnects the power supply to prevent it from another damage. So various simulations were performed on the basis of which results were analyzed, which is shown in the next slides. Here is the three-phase AC waveform, and the above graph is voltage waveform.